different setup. And the question really for researchers is, what do you learn from us doing this? The one project was trying to understand how to teach computation to science students, science undergraduates. And this started by really talking to the faculty in the other sciences at various institutions, talking to education researchers, talking to high school teachers, because there was a close interaction that we had at Purdue between the science education teachers and the high school teachers talking to students that took it, and we developed a course which we sort of had for a small set of students, and which is now evolving actually into teaching to a much larger group, 200 students, and of course in a somewhat scaled back form. And I encourage you to take a look at this project on the website. The second project that I want to say a little bit more about is one that is less than a year old. And there we have, our goal is to actually train more secondary teachers to really be able to teach computer science. I invite all of you to look at your state where computer science education lies in and what's actually going on, and you will not believe what you find. At Purdue, what we see is we have both in science and engineering and technology, we have students that go through the first and second year, leaving the majors, and a fair number that actually want to be teachers. And it's really scary. A large number want to be social science teachers, and they want to be coaches for athletic teams. And they actually have gone through courses that make them perfectly good computer science teachers in high schools. And so what we're in the process of creating is a teaching endorsement. They can become the social science teacher you want to be for whatever reason, but get a CS teaching endorsement so you can teach computer science. And that's what we're in the process of implementing. We are developing a CS methods course which will teach teachers how to teach computer science. We actually are thinking very seriously of putting out grad students that teach the 100 and 200 level courses through this course, because they have no clue how to teach. Okay, and some of these issues, what is taught and how do students really learn, could be very good for them. We work with the College of Education. We work with high school teachers. Actually, we have this summer, two high school teachers are developing parts of the labs for this methods course. We've gone down to the Indiana Department of Education and say, you're requiring your students to take 4 years of math. You're letting them take statistics as a math course. You're letting them take things you don't even want to hear about. Why not computer science AP? And their answer was, sure, no problem, but only if Purdue will count it as a math course. So we went back to Purdue and went with the provost and said, can you count this as a 4 year math course? And actually they said, by tomorrow 5 p.m. send us a document, we'll push it through this summer. Okay? And so I couldn't do this with my colleague Steve Cooper, who's both of us, the provost said they've never seen such enthusiastic people. And Steve, you know what I mean? But I also, and I talked to my friend Maureen from IU and said, you're going to do the same thing at IU, Maureen, right? And we looked at, Steve and I on the flight out, we looked at a lot of your institutions. You look at what the admissions page shows and what computer science is. And if anybody's here from Nebraska, University of Nebraska, you're great. Okay? University of Arizona, you're great, but it ends right there. You don't really, and Georgia and Texas as states, because there you really have worked with the states and with the universities. Look what's going on at your school, because if you want broad impact, draw really the students into computer science, and you draw them in by giving them credit and saying this is meaningful, and argue that it's a math credit. In Georgia, it's a science credit. So this is there are other activities that go on in this project, but this just happened this week. That's why I think it's worth looking at. So here are some of these activities that we are doing. I think working with the people in education gives us a very different view and actually how to assess what you're doing. For them, it's very natural to do pre and post surveys of any activity we do, which in computer science, we just do it. Okay? And I think that is one thing that you learn by other groups. I want to, you'll have the slides, some of these things I've actually said. And a final thing is, in terms of the good activities, here are some the things on the advice. For more junior people, your work can't impact others and have a broader impact, but you need to figure out how to be realistic what you do, and that's part of what we want to propose. And the other statement I made is really important to build on what exists, don't invent the wheel. There are a lot of things that exist. There are exhibits, there are great Harvard people, there are CRAs, there are CRAW, there are CRA people here. They all can help you. So I think, yes, I hope that a lot of ideas will come out from them. Okay? So thank you.